So how you are seeing now this video is also due to the light. The question is, how does it work? So in this chapter, we are going to understand everything, and by the end of the video, you'll be the expert. Not just that, but when you go in a 10th class from 8th to 10th, this chapter again will come with refraction, reflection, all those concepts. But you will, guess what? You will have those advantages. So now let's take a look at this nice figure diagram, this one. And you know what? We are actually going to do it. Are you ready? Say yeah. Yeah, that's good one. Okay. So when I'll show this thing, actually when I'll show this thing, that time you have to answer a few questions like here, what do you observe and all. So till that time, for a moment, read all this because we are actually going to do it. That is related to reflection. Now, what is actually light? Can you tell what is light? Is it a wave? Is it what else other than wave? If it is not wave, then if it is it like bullet, something going in a straight line? What actually it is, that you have to find out. Okay, say okay. Not okay, say yes sir. So yeah, here actually I was searching for something, so I will show you people quickly what I'm doing, and I'm going to change the thing. Hmm. Hmm. Yes, you can see this screen. In this screen, I will search for light, physics, simulation. So yes, this one is good. This one is the intro, my favorite, but I will start with another one, which is even more another level, next level. So let's see what is this, and then I will go with the one I want. It's loading till now, till that time. Yes, this is what I said. This is the one I want, and this works nice. So in the chapter where you see this thing, I'll show here. Here in this chapter where you are seeing this thing, that we are going to do and going to see the actual reflection. Okay, how does it work? How does it look like? And everything. So let's have a light source. So let's have a single ray of light source. Okay, this is light source. Now let's have a mirror, just a normal mirror. And guess what will happen? See, you can see this reflection. Now, if we allow the refraction also, it will be even better. Okay, so to us, it's looking like it's coming from other object or other spot here. So what is going on over here? What actually is happening and what you think is going on? So what you are seeing in this in the textbook one, same thing we can observe in real. In the textbook one, the light going from here, okay, it looks like coming from here. Okay, so that is what in real we are also doing and we are observing here. Now let's, why to stop over here? Now why not to do this experiment, increase it even, experiment even further? What will happen if I take a curved mirror? Let's see. There is some kind of glass. Okay, these are lenses. We'll take care of that later. But first we will have a curved mirror. It's not the curved one. I want curved one. So let me find out. Yeah, that is what happens when you do practically. Unexpected things occur. This is also unexpected, but don't worry, I'll finally get it. On parabolic circular arc. Oh, this. I actually choose the different one. So, yes, see here. Did you observe what is happening? We are getting a nice kind of pattern. So let's see what is happening. The light rays are getting reflected from one surface to other surface, and it's getting reflected multiple times. This is how it is working. So now let's get back to the textbook and see further what interesting things are given over there. And today you will get all the ideas, how it works, what this thing is, and you can ask me doubts related to it. Laws of reflection. So instead of different laws of reflection, why not to actually understand it in real? What is incident ray? What is reflected ray? What these things are? Okay, see here, incident ray, reflected ray. I'm going to show exactly what these things are, and then normal. What is normal? And what this diagram has shown, we are actually going to do it. So let's get back to our simulation. And let's go and see those rays. Not this one, by the way. Where is light? Light. Physics. In physics, we need only light. Oh no. Yes. Here. Now you will actually understand what is going on. Mirror. Did you see? So now how that boy did it like that will do. Also, by the way, in the comments, charts, whatever difficulty you have, you can ask me and I will check it out. I did not check the comment, so in a while I'll check those comments also. And yeah, we'll carry on accordingly. So where was that thing? It was, yes. Now what will happen if I increase or decrease the distance? See, when I increase the distance of the object, the pencil, your pencil, the image is getting very close, isn't it? And is it becoming big or small? Obviously small. Now, what if I, wait, what if I take it very far? See, it's coming totally behind. And what? It's big. Okay. So first I'll say what is incident ray and what is reflected ray, all. And then I'll do more experiments so that you will actually get the whole idea of this thing. Incident ray is simply the one that's going over there. Okay. And why not to understand with plane mirror? So you won't find an image in the plane mirror. Here is the plane mirror. Okay. Uh, this here, this is a virtual image. You can't find it, this image on a screen. So this is called virtual image. When you see yourself in the mirror, but you can't actually visit to yourself or something, you can't touch yourself. That's called virtual mirror. So this is incident ray. Okay. This after reflection, this thing, full thing is reflected or reflected ray. Okay. Then what is normal? There should be a question. They're saying this to perpendicular line, 90 degree, That's normal because it's normally perpendicular. That's it, as easy as that. So it was not that hard. You thought it is a dinosaur. No, it's something very tasty. You can eat it. You are the dinosaur for it. Okay. Now don't laugh unnecessary. Yeah, when it's easy, we like it. Okay. So this is okay. Stop it. Stop it. You like it a lot, but stop it. This is normal. Okay. So these are the concepts. Let's see more what is in the textbook and we'll do all those things. So let's get back to the textbook and good morning. Is it Karthik? Okay, but I'm telling the 8th class one, even though still it's interesting. So yes, Karthik, you can still watch and you can ask your doubts also. Rest of the students also, good morning. Okay. It's good actually in a way for 10th class also. So these all things I said, incident ray and everything, we did this actually. This full thing we did. If you still don't have any clarity or something difficult, you can ask. And this we just now did over there. We saw the normal and everything. Now, angle, that's angle of incidence, and angle of reflection. What are those things? So let's get back and I will show you that also. I made it a little bit simpler one, easier one. Now, if you observe here, this angle from here to here, this angle is called angle of incidence, and this angle from here to here, this is called angle of reflection. That's it, as easy as that, no difficulty, if you understand, by the way. Okay, now what else in the textbook and what else you are scared of? Let's see that also. So let's carry on. And yeah, by the way, it was in high demand by the my 8th class students, so that's why we are doing this one. Normally it will be for 10th class. Main dedication is there is for 10th class because obviously board exam, but all classes are important. So yes, we just now did this one. This one we did just now. Still we'll do more similar experiments. Now there are some questions. Was the image erect or upside down? What was it of the same size as the object? It's asked by the Buzo. So when he asked, see, when the whole sheet of paper is spread on the table, it represents one mirror or one plane mirror. Observe here, one plane. Okay, like that he said. Now he's asking, not Buzo. Buzo will ask later on. Here it is. What does it indicate? It indicates that the incident ray all are same plane. Okay, same plane means I just now draw the image, na? Like here. If you can draw the image on a paper, it is called same plane. Paheli and Bujo performed the above activities outside the classroom. Even we are going to do in our 3D simulation with the sun as the source of light instead of a torch. You too can use the sun as source of light. Just thinking of the sun, I'm sweating. Actually, I'm wearing this thing na, due to it's like it was cool outside. That's why. Anyway, so Bujo remembered that in class 7 he had studied some features of the image of an object formed by a plane mirror. Paheli asked him a few questions. So we will do one by one. Was the image erect or upside down? So image was erect means, you know what? Erect means straight or teda meda or small or big, something like that. So image was straight, okay, not upside down. Like when you see yourself in the mirror, your head will be down or up? Normal only, na? That's called erect. So erect is correct. Was it of the same size as the object? Depends. Okay, usually on the plane mirror, like if you see yourself in a normal mirror, will you look very tiny version of yourself? No, no. So it's the same size. Did the image appear at the same distance behind the mirror as the object was in front of it? Yes, it appeared at the same distance. Okay, we will find the distance now only. I'll show again. Yes. Yes, Karthik, I know you are you. See here. Just a minute. It's not working for some unknown reason. Why that happens every time? When it is too urgent, that time only internet will be gone. And I think you can relate it, na? It's very relatable. So what? I'm not dependent on a single website. Let's do in a different way. But here we can't get the image. So let's try this one, whether it's working or not. I'll open that website again and I'll check it. I'll make it work. Okay, so just a minute. I will refresh this browser. The browser actually got hanged for some reason. Anyway, so let's come back to this thing, the chapter itself, and then we'll go to the browser. I will tell the answer till the browser I reopen. I'll tell the answer till that time. Could it be obtained on a screen? You can't obtain an image from plain mirror to a screen. So no, it's wrong. So I answered most of the question. Now here, did the image appear at the same distance behind the mirror as the object was in front of it? Yes, same distance. Yeah, that's it. Now next question. I'll check once my sound is coming clear or not. And if you can listen to me, tell me. Image formation in a plane mirror. We saw that one. What is this? What is this thing? Can you tell what is this thing? Check once my sound is coming. Yes, my sound is coming clear. Okay. So Likit, Harshil, rest of the students, those who are watching it now or later, them also. What is this thing? Can you tell? What is going on over here? It is, you see, does the light reflect on your hand? Like you see your own image on your hand? No, no. It's because our surface is not smooth like a mirror. Okay, it's like zigzag. Okay, and that's why light get confused where to go. That's it. That is what it has been shown. Okay, that is called irregular surface. And that's why we don't see our faces in all the objects everywhere. My God, if we see reflection everywhere, we'll get confused what is real and what is not real, man. It is like a dream. Anyway, that's nice, by the way. Let's carry on. So, where was I? Recall that in an image formed by a mirror, the left of the, oh yes, the lateral inversion. Okay, we see the things ulta pulta. Like if you see the reflection of your textbook in a mirror, I will try to do that this time. Ulta pulta. So I'm back over here in this browser and I will go back to that thing. Actually this thing, actually yes, this thing. I will go back to that website and then again I will find out that exact physics reflection of the mirror so that you will be easily understanding it. So let's have a plane mirror. In the plane mirror, we'll see the lateral inversion effect. Can you guess what this lateral inversion effect is? Oh, my face was not visible. Now I check the setting. Okay, so lateral inversion, I'll change the object. Penguin. See, penguin face got turned to different direction. Okay, that is called lateral inversion. Arrow won't show that thing to you. Pencil also won't show that thing to you. But still, I'll try to draw. I will try to draw and make sure you know. Let's say you are writing N over here. Okay, so lateral inversion means it will look like ulta. Okay, ulta N. Okay, let's try R. It's difficult to write ulta. R. This is correct one. Now lateral inversion would be something like this. Okay, that is the meaning of lateral inversion. Okay, is it clear now? Okay, chapter is very interesting. So let's carry on with the next of these things, remaining part of it. So yeah, let's carry on. Diffused one means, diffused or irregular means these only light rays are going in different directions. No? That is diffused. These light rays are going in a random direction. This is called irregular or diffused. Then regular reflection is the mirror wala thing. Okay. What is this activity? Imagine that parallel rays are incident on an irregular surface as shown in figure 13.6. This one, 13.6. Remember that the laws of reflection are valid at each point of the surface. Use these laws to construct reflected rays at various points. Are they parallel to one another? No, those won't be. You'll find that these rays are reflected in different directions. Yes, obviously, here you see this light ray is going over here, this is going over here. So their directions are all different. Okay. Do we see all objects due to reflected light? That's a nice question. And the thing is, no. Sun, star, the things that create their own light, we don't see them as from the reflected, like the bulb itself. Okay, bulb generates its own light, converts the electric energy into light energy. Okay, nearly everything you see around is seen, nearly, not everything, but nearly, is seen due to reflected light. Moon, for example, receives light from the sun and reflects it. That's how we see the moon. The objects which shine in the light of other objects are called illuminated objects. Can you name some other such objects? There are other objects which give their own light. Okay, many objects actually give their own light, mostly the bulb itself, which we call light also. Switch on the light. Okay. The stars, as I said earlier, and obviously the sun. And also bright student, you. By the way, you are the best classes student. So its full form, do you know? Bright and energetic students tuition. Sun, fire, oh yes, flame of a candle, and electric lamp, all these things. They create their own light and we see them because of their light. Their light falls on our eyes, obvious thing. That is how we see them. The objects which emit their own light are known as luminous objects. Oh, this they could ask in the exam. The object that illuminate their own light, like the bulb itself or the flame, these are luminous objects. Let's see what this bozo guy is scratching his head for. I have a question. Can the reflected rays be further reflected of if incident on another mirror? Oh, nice question. Can reflected light be further reflected? That's an obvious thing. If you have two mirrors are side by side, or if you go to a barber shop, you see yourself, multiple version of yourself. So yes, it can be done. And we will do that now. So let's see. Let's get back to our simulation. We are back, and let's try to have multiple reflection. So I'll go to this one, and let's have a light source. So something is off with this website browser. So I'll open another browser and I will still make it work no matter what. So I'll copy this thing. I'll copy the address. Not this one address, by the way. I'll copy this address. You can take note of this website. These are useful website, and I keep on searching for the next level amazing website for the students so that they can keep on understanding. It will be good for them. So let's check whether the other one is working. So I'm trying to go on other website. Yes, it's working. So I'll make that simulation work over here. And light source, single ray. We got the single ray light source. Now we talk about the multiple reflection. Are you ready to do that? Let's do. So I got a mirror and it got reflected. One more mirror, it got reflected. One more mirror. See how nice is the pattern. Okay. One more mirror. See how nice is the pattern. One more mirror. One more mirror. One more mirror. Okay. But now these are enough. I'll start again with a better one, even better one. So I'll try to just start a new, and we'll have multiple reflections. The light source, single ray. Okay. But this time I will take a curved mirror. Okay. And let's see what kind of reflection it is forming. See, when multiple reflection is happening, how amazing it patterns it's forming. And let's have one more curved mirror. See, okay, so we can actually get almost infinite number of reflection. Let's try to make it even more greater, further better. Okay, so see how amazing patterns we are getting. Now let's get back to the chapter. What else nice thing it is telling, and what else you are understanding. Good morning. Tarun, you are not going to school, Tarun. If your school has some time, then it's okay, but don't skip it unnecessary. You can watch the video later. But if you are not going to school anyway, or if you are late, definitely then you should watch it. Anyway, so let's get back to the chapter. And let's see what else it is telling. Now, reflected light can be reflected again. Yes, we just now did it. And here also they show the image of the barber. Okay. And our barber also does it sometimes, isn't it? Multiple images we just did just now. Activity 3, take two plane mirrors, set them at right angle. We actually did it. Okay. Then again, now hinge the mirrors using the adhesive tape, and we have to do this. Okay, in front of each other, two mirrors are there in front of each other. Now here is the thing, kaleidoscope. Okay, kaleidoscope will keep on reflecting again and again and again. That once I have shown to my students. Okay, I will do that kaleidoscope thing once more so that it will be easy for you people. See, kaleidoscope is ready. How it is ready? Just to take three mirrors. See, this one is mirror 1, this side will be mirror 2, this is mirror 2, and this is mirror 3. So just combine three mirror, okay, and make a triangle shape. That will form kaleidoscope, and it will show very nice amazing patterns. So are you ready for that? Let's do that as well. It shows next level patterns. So the kaleidoscope we are going to do, we are going to actually check the patterns in kaleidoscope. And for that I need to show my full screen. So let's see whether it's showing or not. Yes, it's visible. Now here is my nice app that will help me into showing the kaleidoscope effect. It will show reflection at multiple places. You'll understand how nice images, diagrams, stuff like that it forms. So let's simply have a color, and let's just make put something which it is not doing it. Now why? Don't know. Okay, let's have a brush. Now let's try. Okay, so let's have another color. Okay, so you see multiple reflection, it's forming how nice, amazing reflections. Now let's have some star like effect with different colors. Let's have some sign effect. Let's have some lightening, under lightening. Oh, let's try some, some curve like or diagram like. Yes, that's kind of good. So now what else? It's actually, I can't stop it. It's very nice. So let's try some more effect with different colors. Let's try to shade it. It's nice. So let's try some more different effects. Maybe some ball like thing. Not that great. Hey, let's make that line. Oh, now it's good. Yes. Now let's try some sun-like effect. Let's imagine if a pink beautiful sun is shining, how nice it will look. Oh, good. And some planets are following it. Wow. So kaleidoscope can produce this kind of amazing patterns. Okay. I have shown my full desktop for the purpose of showing it, but why not? Okay. So one more thing, keep in mind. These sides you are seeing, uh, let me use some different color. This is a reflective surface over here. This is a reflective surface. Okay, the lines I have shown, and everything has reflected around it, and it formed even more further better. Looks kind of very good. But now we have to go back to our chapter. So let's get back. What is inside our eyes? Yeah, man. Sunlight, white or colored? Oh, sunlight white or colored? Wait a minute. I can actually show you people sunlight is white or colored. Okay. So let's first check the sunlight and then we'll go further. Let's get back to our software and I need to search for physics simulation. So physics light simulation, and then let's try. I'll try to find out the sunlight. Yes, I think we can find the sunlight effect over here. So prism thing. So here is our normal. Here is our normal sunlight. Okay, the one we see. Generally, we think it is white light, but what if it reflects through a reflecting surface, kind of prism? See the rainbow. Okay, observe here. Let's take it a little further behind so that rainbow would be more clear. Okay, and I'll try to reflect it further back so that rainbow would be further clear to you. What? Not upward, downward. Wait, I'll do that thing. That setting I'll do. It's so interesting now that it's difficult to uh, stop doing it. So here we are finding that when we split the light, we can see very nice different colors. So this is what generally we see the rainbow. This is exactly the rainbow thing. Okay. Here you are seeing different color. Here you are seeing different color. So Vibgyor, violet, Vibgyor, V-I-B-G uh, O-R. Violet, indigo, blue, green, yellow, orange, red, Vibgyor. These major light we see when the light gets refracted. Okay. In droplets, water droplets also that happens, and we see the sunlight. It happens a slightly different way. Okay. It actually returns back in water droplets. I'll try to show that also, returning back thing. So let's remove this and let's bring a spherical kind of thing. Thing here. So in water droplet, actually this happens. Internal reflection it happens. So refraction plus reflection, both thing happens, and that's how we see the rainbow color. Okay, this is why rainbow forms in the sky. So if we are down somewhere on the earth, in the sky to us it will look like rainbow. It was quite interesting and nice. Now let's see human eye. So I will give a introduction of human eye, and I'll tell what are the different part of it, how we are able to see due to the light, ciliary muscle, iris, lens, cornea, retina, optic nerve, all those things I'm going to show you people. What this guy is doing, by the way, get a square piece of cardboard. Okay, make two holes. Okay, okay, draw one side cardboard. Twist the string and make the card twirl rapidly. Okay, do you see the bird in the cage? Okay. So we have to rotate it rapidly. One side will be the bird. Let's say over here I made the bird diagram. Over here we have to make this cage diagram. Okay, and then we have to rotate it rapidly. It will look like when the fan rotates, it looks like whole single circle, na? So that time it will look like the bird is inside the cage. So now let's see what are eyes, what is our eye, what are different function of the eye, what are different parts of it, and pretty much almost everything about the eye we are going to see now. So we'll observe these parts. Actually, we are going to see these parts: the lens part, the iris, you see the color patterns in the eyes. Okay, the color, the brown color or blue color of the eye, that is the iris. Whereas there is sclera or something like that. This sclera kind of name is there, the white part of the light. Okay, here it is vitreous humor. HOUMOUR, something like that is the spelling. Okay, but that's vitreous humor. And here also there is a humor. Okay, these humor are colorless, transparent gels, those humors. So let's see, where is this pupil, retina? Okay, I'll stay in a while. Till that time, first we'll see the human eye, not light, human eye. So are you ready? Let's start it. Can you see this thing? So we got Mr. Skeleton, my favorite guy. He helps in learning a lot. Let's see the eye, human eye. Let's say hi to this guy. Okay, this is what the human eye is. This is that tear gland. This is also tear gland. It helps the eyes a lot. Okay, now this pattern kind of thing you are seeing, this is the iris. This pattern wala part, this is iris. What it does, it controls this gap. Through this gap the light enters in the lens. I'll show where is the light, I mean where is the lens. Here is the lens. So this part is the lens. My circle is too much circle, na, spherical. This part is the lens. Okay, and this is optical nerve. This is optical nerve. This only sends all the signal to our brain. It's like the cable connectors connected to our TV, like that, or a camera also you can say, or webcam. So it sends all the information. These are the ciliary muscle. Okay, when some of you are battery, na, some children will get battery, that is the, some children will get the specs. Okay, it's simply due to the ciliary muscles get weak. These ciliary muscles. Here you are seeing this thing. These are all ciliary muscle. So if these muscles got weak, then the children can't focus easily, or people, while reading or while seeing far object. That time they need the specs. Okay, so actually nothing gets damaged in the eye at all. Okay, when you get eye problem or eye defect, it's not a big problem. The thing is your ciliary muscle is actually got weak because you keep on seeing the phone like whole day night 24/7, as if you phone is not the device, you are the device for the phone. So that is how the eye get affected. Okay, so can you say the blue color is what and red color is what? What is what and what is not what? Can you tell me for a, like, can you try for telling that? Guess once. I will see, don't forget, I will see your comments also. So the blue one is blood vessel, and red also obviously blood vessel. The this blue one is this thing, what we call it, deoxygenated blood vessel, and the red one is deoxygenated blood vessel. Deoxygenated or oxygenated, keep in mind the red one always contains the oxygenated with more oxygen, O2, whereas the blue one contains deoxygenated. Okay, if any blood comes out of these vessels, not in the eye, like when you get this thing, na, when you get any injury on your hand or leg anywhere, Did you ever see this blue blood coming out? No, no. You are not octopus, obviously. So how you will have blue blood coming out? Okay. So blood is always red. This blue and red is just a representation that it has carbon dioxide or oxygen. Okay, okay. It was funny. Stop laughing now. Okay. So, by the way, remember I said in the eye there is a gel. So this thing is not empty. It might look like empty over here. This thing look like empty to you, na? No, there is. It's not empty. It has something filled it so that it will be strong. That is called vitreous humor, as I said earlier. But in lens also there is a humor called aqueous humor. Okay, that's uh, in between um, lens. So your eye has iris, yes, aqueous humor, yes. So aqueous humor is correct. This part, yes, I remember now. So yes, this part you are seeing now. See here, here. Also, so no, I will show. So this part over here, this filled part is filled with aqueous humor. Okay, it is a gel-like substance. Now the question for you people: what these things are and why these are, like why it is filled with, why this is filled with the liquid, and why this is filled with liquid. Why this is filled with liquid inside the eye, and why this part is filled with liquid? Because how when the air is filled in the tire, it makes the tire strong. It actually helps the eye to retain the structure, also makes it durable and strong. That much amazingly the eye is designed. Okay, so these are the things. One more thing is there, this thing, a line like thing you can see over here. See this, a line like thing. Okay, so it doesn't have currently a function, or might be scientists discover later on this line like thing. Okay, but when we are baby, or when our body gets produced as a baby, that time our lens forms. Okay, so the liquid goes from here and forms the lens. So that this line like structure forms at that time. After that, it doesn't do anything. It doesn't have a major role after that. But yes, that is what this line is. Now let's see if anything remained from the one I have already said. If something remained, I'll keep on telling. Further, I'll tell. So let's see. Blind spot. Yes. So they say that here is the blind spot. I have not observed any blind spot actually, but they say here is a blind spot, and here somewhere is very bright spot. You can see very clearly through the retina. So that's what they said. Also, how we can see different color and how we can see the brightness. So there are conical type shapes that show us color, prism like actually thing, and there are rod like shape cells in retina. In retina means in this part, the wall of the eye. They help us to see these different colors and brightness. What else is there? Is there anything else? Yes, for 1/16th of a second, the image will be still be there. Okay, I'll try to do that thing. So I'll move some object very fast and try to see its image is staying there or not. So I'll just scroll this page only up down very fast. See, it's looking like it's stuck at one place. Okay, what if I do an experiment now? Let's do an experiment. Okay, and I will change the color in your eyes. Are you ready? Say yes, sir, or say yeah. Oh, very good. You are like super ready. Okay. So what I'm going to show is an image, okay, which has negative color. Negative is not the negativity wala thing. Negative color means it will be one thing and it will look like another thing. Okay, so it's very simple. You have to just observe something. I'll show in a while, and that while is now. So let's get back to this screen. Oh, actually, I'm to another screen. I'll bring back to that screen what I'm talking about. So just a while. In that, what you have to do, I'm telling. In that thing, you have to see at a spot, and immediately you have to change the spot. So I need white background also. So white. No, why white background required? Okay. Now what you have to do is you have to observe this black spot. This black spot. In this black spot, there is this blue dot. In this near the blue dot, there are some irregularities. You have to keep on observing that, like totally without blinking your eye or without changing at all for a few seconds. So I'll start the timer now. Don't move at all. Keep on watching, observing. Okay, and a magic can happen based on what you are doing. Okay, see. Can you see those greenish kind of light kind of thing? Greenish. There are greenish blob-like thing or sphere-like thing. That was just the retention by the eye. Means eye retains the image for some time. Okay. I will try to do some more thing so that you will understand what I'm talking about. If I remove this light very fast, see, you can see the dancing light. Okay, but it is looking like it's there for some time. Or when you see this fan in your home, okay, imagine if some fan is running. See what you see, instead of seeing a circle like these blades. Let's say there is a fan. I'll make the fan. uh, let's say this is the spherical part of the fan. Let's say this is the fan, but when it's running now, you don't see this structure. You see something something like this structure. You see, okay, like as if there is not a single blade or three blade, but it is full a structure like that, you see. So due to that, it is due to that for 1/16th of a second, 1/16, so that will be like 0.0 uh, 6 0.06. So 0.06 second. Okay, for 0.06 second, that image will stay in your eyes. If the fan is rotating faster than 0.06 second, then it will look like many blades are there or many fans are there or it's whole sphere. So in movie you see hero's hand will look like so many hands like that. So it's due to speed. Okay, it's that is the effect. Very interesting effect. It is used in the movies a lot. Anyway, one more information they ask in the exam. The proper distance for comfortable distance for reading is 25 centimeter. So when you read or watch the screen of the phone from too close, and then you get the battery, it's due to that thing only, that you don't care of your eye. By the caring of the eye, I remember one more thing. Do you know that we have to wash the eyes? Now you have to try to wash it as many times as possible, because that helps our eyes a lot with clean water. Okay, and yes, you should not put hot water on the eyes. Don't do that. Cold water is good, but not the hot one. Okay, now care of the eyes. Okay, they also have told. What is this? Did you know animals have eyes shaped in different ways? Eyes of a crab are quite small, but they enable the crab to look around upward. Yes, true. Then so the crab can sense even if the enemy approaches from behind. Butterflies have large eyes. Yes, here. Even the dragonfly. So are you ready to see their eyes? Let's see their eyes. So where's that thing? Yes, I think you can see now. So here, see how big is its eye? Okay. So through this eye, it is able to see. It will have some small hexagonal structure. It's B. Okay. It's saying hi to you. Say hi. Okay. So our B is ready for action. Hey B, can you show some action to us? Wow, we had nice action. Anyway, so yes, I have shown this thing to you, and let's carry on back to the chapter because more interesting could come. So let's just to find it out. Okay, so just now I have shown the butterfly has that small hexagonal structure. Okay, so the big eye is actually made by thousands of little eyes or little surfaces. They can see not only in front and the sides but the back as well. A night bird, that's owl, can see very well in the night but not during the day. On the other hand, daylight birds, eagle, kite, can see well during the day but not in the night. The owl has a large cornea and a large pupil to allow more light in the eyes. So owl can see in the night also. Also, it has on its retina a large number of rods and only a few cones. So owl can see brightness more better than the colors. The day birds, on the other hand, have more cones and fewer rods. Cone can show you the color, so the day birds can see the color more better. These are some important things. Never look at the sun. Okay, lamp or laser. Don't point out laser directly to yourself, or don't look at. Never rub your eyes if particles dust to your eyes. Wash. Yes, you should wash. Don't rub it. Always read at the normal distance, just normal 25 centimeter or around. Don't get too close or too far. And yes, there is one last thing, that Braille language. They touch the thing with the hand, those who can't see, and they can feel with their hands. So that is called Braille language, Braille or Braille. There are some other optical aids. Aids means useful things. So non-optical aids include visual aids, tactual aids, using the sense of touch, auditory aids, listening the things, kind of. So Braille language was made by Louis Braille, who was blind, uh, and he generated this system, Braille language. Okay, here you can see T means two dots, then two dashes, then two dashes, whereas A means one dash, one dot, and T means dash, then dot, then two dots, then uh, dash, dot, and then dash. So if we write all these things together, the blind people can see EAT. That's cat. So it's an example of Braille language. Just by touching the dot and gap or spaces, they can understand what word it is written. That's the Braille language. So it was adopted in 1932. They can ask in the exam. So this is Helen A. Keller. Okay, and what she did. Helen A. Keller, an American author and lecturer, is perhaps the most well-known and inspiring visually challenged person. She lost her sight when she was only 18 months. Oh my God. Poor baby. But because of her resolve and courage, she could complete her graduation from a university. She wrote a number of books, including Story of My Life in 1903. Wow, man. See, you people give up just before exam or just even studying, And here this is, she lost her vision, she could not see, but did not give up, she got her spirit. Man, that's called spirit. Okay, so we must praise her. Okay, be happy, and the inner happiness will come out with your willpower. So that's it for now. Okay, if you get more doubts, you can ask me more, and if you forget my channel, you can search, I think, pandesar.bestclasses. Okay, I think, because that is a quite lengthy thing, so I'll tell my channel thing, so that if you forget, you will be able to search it out. At bestclasses.pandesar is the channel thing of mine. Here, where is that? Yeah, so this is bestclasses.pandesar. You have to type in the Google at best classes. If you forget to subscribe, but I know you are smart, you will just subscribe it so that you will not miss it ever. Pandey sir, in the Google, in the YouTube, you have to type this in the YouTube, then you can find my channel. So that's it. Bharat Mata ki jai, and best of studies. Bye.